let us try to design a latch which we call it the SR latch. SR latch is nothing but set reset latch. Okay, S means set and R means reset. Okay, so if I want to design set and reset latch, so let us see how it looks like and how it performs actually. Okay, so set and reset latch, performance of set and reset latch is important. So let us try to understand it. Suppose yeah, because I have to design with the help of NOR gate. So let us assume I have a NOR gate. Okay, and this if see, just like what we did in the previous slide, we can also do the same. Okay, so the same kind of things can be done if like the output of one inverter is connected to the input of second inverter, and then output of the second inverter is connected to the input of the first inverter. So this is what we did previously, and similarly we can also do for this as well. But because the NOR gate has two inputs, so we will get two additional inputs as well, which can act as a control. Okay, so if we can go back to the previous slide, in the previous slide we had the input, but the same input here it is unable, we will be unable to control it, because initially if I have kept it at logic 1, then I need to remove it. Okay, and then it will work as a latch. But if we are utilizing two input logic to design this one, so in that case you do not need to remove it. Based on the states of these inputs, you can decide whether what kind of logic I have to hold. Okay, so this is why the OR or NAND kind of structures are required to really make the latch. Based on these states, you can control the outputs. Okay, so this is how the SR latch can looks like, and this is how we can make the SR latch with the help of NOR gate. Yeah, so the first input, let us consider the first input is reset input, and the second one is the set input. What is the meaning of all these things? I will tell you. Okay, so we have two inputs, set and reset. Set and reset means simply if I want to set the output at logic high, then this input should be high and this should be low. And if I want to reset the output, like whatever the Q I am considering, okay, the output Q, if I want to make this Q as logic 1, in that case I need to activate this set 1 and deactivate the reset, and then the output will be logic 1, and the vice versa case for logic 0. Okay, so this is how it works. How it is working, I will tell you. Just wait, and I will explain each and everything. Okay, if we try to rephrase this structure, so how this structure will look like. Okay, so let us try to see it. Simply I have a one NOR gate, okay, which is this one. Okay, second NOR gate, like output of the first NOR gate is connected to the one of the input of the second NOR gate. Yeah, so I have a second NOR gate as well, and the output is connected to the one of the input. Okay, and simply the output of the second inverter, second NOR gate is connected to the second one of the input to the first NOR gate. Okay, so this is how the structure looks like, where if this is the first first NOR gate, so this one will become the reset input. Okay, so this is the reset, and similarly the second input will be the set. And if I'm considering the output of the first inverter is the QT, okay, and similarly the output of second inverter will be QT bar. There was a disturbance in between, or it is continuity is there? Can anyone acknowledge?
Yes, sir.
Okay, fine. I thought there is a discontinuity. Fine. So this is how I will get the different output logics based on this one. Now let us try to validate how this circuit behaves. Okay, so the behavior of circuit is really important. Okay, so to understand the behavior, let us try to write the expression. Let us assume QT is the output at time t. Okay, so what will be the QT plus 1 after t plus 1, or on the next cycle? On the next cycle, what will be the output? Let us try to understand that one. So QT plus 1 is, can anyone tell me what is the QT plus 1? this is the qt, and I want to calculate qt plus 1 on next time state. Okay, so if you see here, this qt is nothing but is the output of this NOR gate, and the output of NOR gate is nothing but this is one of the input which is r, and one of the input which is qt dash. Okay, so the qt plus 1 is nothing but this is the NORing of r and the qt bar. Okay, so the r plus q bar t whole bar will give you the qt plus 1. Similarly, if you want to calculate the second one, qt bar plus, complement, so qt plus 1 complement, this will be, yeah, I want to calculate qt plus 1 from here. So one of the input is set and another input is qt, so I can write s plus qt complement. Okay, s plus qt complement. Okay, so these two are the equations for qt plus 1 and qt plus 1 complement. If anyone has any doubt on at this point, you can ask the question.
Excuse me, sir.
Yeah, please.
Sir, how the two inputs are qt and q bar t?
Yeah, how these two inputs are qt and q bar t? Just see the property of this NOR gate, how the NOR gate looks like. Okay, so let us try to see. The NOR gate property is, yeah, let me make the NOR gate. Okay, x and y, these two are the input, and this is, let us assume it is z. So can anyone tell like what is the condition for inhabitants when it will be inhabit? The truth table for, let me draw the x, y, and z, 0 0 0 1 1 0 and 1 1. Okay, so what is the output of this one? This is 0 plus 0 complement, that will give you 1, 0 plus 1, that gives 1, and then it will be 0, it will be 0, it will be 0. No, 1 plus 1. Yeah, so this is the truth table for the NOR gate. Now if you see here, if I'm considering any of the input is something like, if it is 0, then it will act as an inverter, and if it is 1, it will be, I think I made some mistake. If I have connected 1, so yeah, this will be tied to logic 0. Yeah, so basically what happens, what was your question? Can you repeat? Actually, I forget the question.
Sir, I was saying that how the two input outputs are qt and q bar t.
Outputs are qt and q bar t. Yes. See here. Suppose one of the input here, like see here, if you see, if one of the input is 0, okay, if one of the input is 0, so whatever the input I will provide through any of the NOR gate, that will give you the complementary in nature. So if you will give 0, then you will get 1, and if you are giving 1, then you will get 0. So if they are connected to, like if one of the input is 0, let us assume it is 0, so whatever the input I will get here, that I will get the complementary at this point, and vice versa. Like if here I have the qt, and this, let us assume this set is zeros, this both are set to 0 initially, but initial condition is like r and s are 0 0. So if they are 0 0, what it means, one of the input of that NOR gate is 0. So whatever the second input will be, that will be complementary, output will be complementary in nature. Okay, so let me see it here. If I'm considering r is equal to 0, and initially let us consider the output of the first inverter is qt, first NOR gate is qt. Okay, so if it is qt, what it means, if this set is equal to 0, so the output which I am getting after the second NOR gate, that will be complementary in nature than this one. And if it is in complement, and vice versa, simply if it is the qt bar, then the output will be qt bar and bar, so bar and bar will cancel out, you will get qt.
So initially r and s are 0.
Yes, yes. So in initial condition, I'm considering they are zeros.
Okay, sir.
Okay, you got the point? Doubt is clear?
Yes, sir.
Okay, fine. So this is all about this one. So let us try to analyze few things about this RS latch. Okay, let us try to make a characteristics table of this SR latch. Okay, so how the characteristics table will look like? Here I have three things. Set and reset are the input, and QT is the present input, and QT plus 1 is the next state. Okay, yeah, QT is the past and QT plus 1 is the present input, whatever you can say, it's not a problem. Okay, so let us try to see how the truth table will look like. So there is possibility, like if I have a three variables, so the total possibilities are eight possibilities are there: 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, now let us try to calculate the outputs. Okay, what is the output of all these things? Let us consider the first case. If QT is equal to 0, S is equal to 0, R is equal to 0. Okay, so what will be the QT plus 1? Just check it out with this expression. Okay,
0.
What you are getting?
0.
0. QT plus 1 will become 0. And what about QT1 bar?
1.
It will be 1. Yes, so just try to check it out from this expression. See here, S is equal to 0, so 0 plus QT is 0, 0 plus 0, that will give 0, and the complement that will give you 1. Okay, so QT plus 1 bar will be 1. So what it means, you need to refer, the previous state was QT and the next state is QT plus 1, and both are same. What it means, what was the state in the previously, that will give the same logic. So the output here, remark is the previous state. Previous state 0 will be reflected at the output QT plus 1. I am referring QT plus 1. Now, can you tell me what is the output for the second state? Second case?
0.
0. And again, we are getting the same thing. QT plus 1. What about the QT plus 1?
So it will be the complement of QT plus 1, so it will be 1.
Yeah, no, but it is, yeah, definitely it looks like a complementary, but for now you can say it is complementary, but with next conditions might be you will get some difficulty. I will tell you what those difficulties are. So it is not just like whatever the QT I am getting, I just need to complement it. No, there is a problem. Okay, so these are some problems with the SR latch. That is why I just wanted to tell you. So you need to calculate from this formula.
So 1.
Yeah, so again it will be 1 because it does not depends on R. Okay, so now if you see here, it again looks like what was the previous state, but because I have just activated this R, so R simply means that this is going to reset the output. We will the same kind of concept will be I will just tell you when I will explain this case. Okay, and when I will explain this case, then you will be able to understand how we are resetting. Okay, but as of now, whatever the previous state was, I'm just assuming that it was 0, and again I'm getting the 0, so it looks like it is maintaining the same logic. So you can say it is the previous state 0, but it's not like that. Let us try to check in other things. Let us assume, like if you have another other kind of, like if the previous state is 1, yeah, let us try to consider this state. Okay, this one. If the previous state is 1, can anyone tell me what is the output? QT plus 1 in this case. Yeah, this case
1.
and this case are the similar, like just qt is changing, the previous state is changing. Okay, so what you are getting output? What is the output?
0.
0. And if it is 0 and the qt plus 1 bar, you will get 1. So now if you see here, previously the input was 0, but it is getting reset to the 0. Okay, because here the previous state was 0, so again, because it will reset, so again it will become 0 only, right? So it looks like it is reflecting the same output, like previous state is copying, but no, it's not like that. If you see here, if the previous state is 1, okay, so if the set and reset inputs combinations are 0 1, means like if the reset pin is activated, reset input is activated, the output is going to reset, because the previous state was 1, it is resetting. So we can call these two states as a reset state. Okay, so this is resetting and this is also resetting. Okay, so this is one thing. What is the output of this third stage?
In the qt plus 1 should be 0 in the second case.
Qt plus 1. Yeah, so it is 0, right?
No, sir, in the second case, qt plus 1 bar.
Here,
Yes, sir. Its complement should be 0.
this one.
Yes, sir. Because s is 0 and qt is 1.
Yes. So just no. So I will explain this later on. Just let me finish these things and then I will explain. Yeah. Just if you can see here, qt is equal to 1. So 1 plus s is here 0, and that complement that is giving like 0. Okay, so you are saying that this should be here, in this case it should be 0 instead of 1. But what happens if we are talking about, yeah, so please wait, I will explain you in more detail. So it looks like, yeah, this is absolutely correct observation. Wait, let me finish these things, then I will explain this point. Okay, so let us first consider the third case. Okay, and if I'm considering the third case, if qt is equal to 0 and set is equal to 1 and reset is equal to 0, then what will be the output? Qt plus 1.
0.
Output qt plus 1 is 0.
Yes, sir.
Okay, output qt plus 1 is 0. How it is 0?
So qt bar should be 1. 1 plus 1, it comes out to be 0. 1 plus 0 comes out to be 0.
So again, you are saying the qt plus 1 should be 0. Okay, and what about this qt plus 1 complement?
The 0.
It is 0 and also this is 0. But you know that is these states are possible, like, because we know that qt plus 1 and qt plus 1 complement, these two are complementary in nature. Okay, and from this expression we are getting like qt plus 1 is 0 and qt plus 1 complement is also 0. Yeah, this is absolutely correct if I'm considering these two equations. But in reality, these two are always in complementary in nature. So what will happen? There is a problem here. So during the intermediate state, at this state the complementary rule is not following. Okay, so what it will do, it will wait for the state table. So it will wait for the next state, like once this qt plus 1 will be changed, then it will change its state. So what it will do, it will consider qt bar as a 0. Let me repeat again what I'm saying. This is, yeah, this is absolutely very important, because we have set one of the input, which is this one. Okay, we have set one of the input, and the second input for this NOR gate is nothing but this is the qt. Okay, so what will happen? This is 1, this is qt is equal to 0. So 0 and 1, that will give you about 0, output 0. So what will happen, because both the outputs we are getting 0 0, so this is not actually possible because both the qt and qt bar are complementary in nature. So it will first wait that qt bar should reflect. So once the qt plus 1 bar will be reflected, then that will be considered as an input for the second one, and then the qt will be you can get it out. So because it is not following the complementary rule, so these are some of the problems. So to overcome that problem, we need to change the design. How it can change, I will tell you later on. Okay, so once this you are getting the qt that is 0, because you are resetting this one, you have just set one of the input which is at logic 1. Okay, so because you have set and the set is with respect to this qt bar, so the qt plus 1 bar will become first 0, and then that qt bar will be considered as an input for the second NOR gate, and then this qt will be reflected. So once you will get this qt1 bar 0, okay, and the 0 plus 0, that will give you the 1. So you need to change the state, or you need to wait for some time to get qt plus 1 reflected to logic high. Okay, so this is how this will come. Okay, so this state was really very tricky actually. Okay, so and this is really important also. Okay, so you got the point how it is getting changed. So based on this formula, absolutely it looks like these both should be 0, but these are not possible because both are the complementary in nature. So if both are complementary in nature and they are not following that complementary property, in that case, because we have changed the state of the second NOR gate. So the the second NOR gate will reflect its output, and that once this qt bar is becomes 0, then that will be considered as an input for the second NOR gate, and then qt will be reflected. Okay, so based on formula, it looks like both should be 0, but it is also important that both should be in the complementary in nature. And of course, one very important thing that we should note here, because we are setting this the second NOR gate, so this will perform the operation. So whatever the state I'm changing, if I'm setting this r is equal to 1, then the output is responsible based on this NOR gate. If I'm setting only this set 1, then outputs are responsible based on this NOR gate. But if I'm setting both the reset and set 1, then outputs are responsible based on this one. Please remember what I'm saying. This is really very important point which I'm saying. Let me repeat it again. If I have a structure something like this, and if I'm setting it to 1 and resetting it to 0, then this NOR gate will decide what will be the output, and accordingly they will change the states. Okay, so first the qt bar will come out, then qt will be decided. If I'm changing a state, like if I am making r is equal to 1 and set is equal to 0, in that case this NOR gate is responsible to give the output, and then after qt bar will be reflected. But if we consider the next case, if qt is equal to 0 and set and reset is equal to 0 0, then what will happen? Because we have activated both the NOR gates, I'm providing 1 and 1 to both one. So can anyone tell me what is the outputs? Yeah, so this is what we can say this is the set state. Can anyone tell me what is the qt plus 1 for the fourth case?
0.
It is coming 0. And what about the qt plus 1 bar?
0.
0 and 0 again. Okay, so we are getting 0 and 0. But is it because we have activated both the NOR gates, and I just told you the NOR gate which was activated with logic high is responsible to give the output. Okay, and here we have applied logic 1 to both the NOR gates, so I'm assuming that both the NOR gates are responsible to give the output, and based on that qt and qt bar both should be 0. Okay, but this is not correct. So what will happen? There will be a racing, like which of the output is giving logic high first or logic 0 first, and that can be simple. Suppose I have a 2 NOR gate, and this NOR gate is fast and this NOR gate is slow. Okay, let us assume this is the fast one and this is the slow one. Then what will happen? This first NOR gate will give output 0 earlier than this one. Okay, so if and before performing any operation with the second one, the first NOR gate has given the output. Okay, so then this output will be sampled here. Okay, and then if I got 0 and 1, then it will give some other states. Okay, so
it will be same as 0 then.
Huh?
Sir, 1 plus 0 bar also gives 0.
Yeah, it will be 0. But because, see here, one important thing is, like, both the OR gates are in the racing condition. Like they will they will try to maintain the logic 0 on both states. If you see the previous case, this one, in this case, what happens? Once I got the output Qt1, because I just set it out, so this is responsible to give the output, and once this is set, then that is responsible to change the state of Qt. But because in the fourth case I have given output 1 to both the NOR gates, so both are responsible for the outputs. So it is not like they need to wait for some time to settle down the output. So it is not possible in this case. In this case, I will get always output 0, 0. And this is not the acceptable condition. And this condition is known as the intermediate kind of state. Okay, so this is known as intermediate state. And here the rules are not following. So this condition is not acceptable actually. Okay, so how to remove this problem? I will tell you later on. So this state, we call it the intermediate state or indeterminate state. Okay, so indeterminate state is not acceptable in the flip-flop. Now let us consider the other three cases. If I have a q is equal to 0, then q is equal to 1, and set and reset is equal to 0. If you apply the formula, you will get the output qt plus 1, 1, and this will become 0. What it means? It is the previous state 1. Now let us consider this one, which we are expecting that will be reset. So if qt is equal to 1, okay, so let us assume the qt is equal to 1 and set is equal to 0 and reset is equal to 1. So what it means? It means that this NOR gate is responsible to give the output, and because this is 0, this is 1, so this will be 0. So this 0 will be sampled here and 1 will be sampled here, and it will change its state from 0, because this is 0, this is 1, so the state of the first NOR gate will be 0, and then this will be sampled to this one, and then 0 plus 0, that will give you the 1, because this will decide, the first NOR gate will decide what will be the output. Okay, and because both the NOR gates are not responsible, so they will get for some time to get output settled down. Okay, so this is how it can say the reset. I think the Arpit asked the question. I think your doubt is clear, right?
Yes, sir.
Okay, so this is this case. Now let's talk about the next case. Okay, what about the next case? If I have qt is equal to 1 and s and r is equal to 1, 0. So here, if you see, the set is equal to 1, set is equal to 1, qt is equal to 1, so 1 plus 1, that will give you 1, and that complement is equal to 0. So qt plus 1 will become 0. And what about qt? Qt plus 1 bar will become 0, and qt plus 1 r is equal to 0. So 0 plus 0, and that will become 1. So here I will get 1. So what it means? I am setting it. This is the set. And similarly, if qt, r, and s are 1, 1, so what is the output? Yeah, this is same like this indeterminate state, because we are setting both the r and s to logic high. Okay, and I'm considering the qt is equal to 1. So they will give you some indeterminate state, which is the 0 0, and it is not. Yeah, this is same like this state. Okay, so I don't need to explain it again. Okay, so this again, this state we call it the indeterminate state. Okay, so these two states, this one and this one, is not acceptable in the flip-flop designing. Okay, so this is all about the characteristics table of RS latch.